everyone, and welcome to today's lesson, which is on dividing radicals. So we're going to focus on two different things. The first thing is we're going to focus on just dividing basic radical expressions. And the second one, we're going to learn what rationalizing the denominator means. Okay, so those are our two goals here. Okay, so first off, for a radical expression to be simplified, there cannot be the number in the end, or even the variable in the end, cannot be divisible by any perfect squares. So for example, if it is the square root of 8, we can't leave it like that. We have to split it into the square root of 4 times the square root of 2, which would be 2 square root of 2. Okay, so that's what I'm talking about with the first one. Second one is we cannot have a radical in the denominator. So in other words, we can't leave it as the square root of 7 down there. We got to figure out a way to get rid of that radical in the denominator. In the numerator, it's okay, just not in the denominator. And number 3, all fractions must be simplified or reduced. And that sometimes can be the hard part, is figuring out how to simplify those fractions. All right, so let's go with kind of how to start. So if we have a square root and we have a fraction inside the square root, the first step you want to do is to split it into 2 separate square roots. So we're going to take the square root of the numerator, and we're going to take the square root of the denominator separately. We're always going to try to simplify those if we can. So remember, you can simplify inside with inside or outside with outside, but you can't simplify outside and inside together. And sometimes we may have to simplify a second time. So I'll show you kind of what that looks like. I always try to simplify first to make numbers smaller. All right, so first one, I try to simplify inside of here. Is there something I can divide both 64 and 49 by? If not, we're going to go ahead and split them. So we're going to split the square root of 64 over the square root of 49. And lucky for us, I know the answer to both of those. The square root of 64 is 8, and the square root of 49 is 7. I always see if I can simplify again in the end. Here I cannot. That's my answer, 8 over 7. All right, number 2, they already split it for us, so that was nice. Now look what I can simplify. So you can simplify, again, inside with inside and outside with outside, but you can't simplify one inside and one outside. So in here, I don't have any outside numbers, so I'm going to ignore that. But I do have inside numbers I want to simplify. Now, I can't take 8 and divide it by 50, but I can divide both of these numbers by 2. So if I divide them both by 2, I get 4 on the top, and on the bottom, I get 25. On a side note, I can also simplify my x's. So I have x to the 3rd over x. Just as a quick refresher, we have x times x times x on the top and just an x on the bottom. And if I kind of simplify that or cancel out one on top and one on bottom, I'm left with 2 x's on top. So I'm left with x squared. The shortcut was that we subtracted those exponents. 3 minus 1 would give us 2 on top. All right, so I simplified my numbers, I simplified my variables, and now I'm going to square root each of them. So I'm going to start with the bottom. Square root of 25 is 5. The top, square root of 4 is 2. And the square root of x squared, remember you see how many pairs there are. There's 1 pair, nothing left over. So our answer here would be 2x over 5. Now, I know we've only done 2 examples, but go ahead and try these next 3 on your own. See how you can do. So go ahead and pause here, and we'll go through the answers together. All right, here's what you should have gotten. On the first one, I told you I like to simplify first. So I would have taken 144 and divided it by 9. That would be, in my opinion, the easiest way. Now, if you didn't do that, and you split them each up separately, you could still get the same answer. That's kind of the nice thing on these. There's lots of different ways of doing the problems. So if you split them up and did the square root separately, that would give us a perfect square on top, which is 12, a perfect square on the bottom, which would give us the answer of 3, And then you just can't leave it like that. Always see if you can simplify again in the end. 12 over 3 is 4. Now, if you would have simplified and divided 144 by 9 right away, that would have been 16, and the square root of 16 is 4. So option 1 and option 2, you could have done either way and gotten the answer of 4. All right, next one. They are both inside, so I'm going to simplify here. I'm going to start with the numbers, 8 and 2. I can divide them both by 2 to get square root of 4 and square root of 1, but I'm not going to put 1 on the bottom. And then the a's, I have 1 on top and 5 on bottom. I cancel them out, the a's on top go away, and I'm left with 4 on the bottom, so I have the square root of a to the 4th on the bottom. And after I'm done simplifying, I'm going to square root each one separately. So the square root of 4 is 2. And the square root of a to the 4th, how many pairs do we have? We have 2 pairs, so a squared. That would be our final answer on number 4. All right, and last, number 5. I can't simplify anything. So I'm going to split them. I have the square root of 25y to the 3rd on the top. And on the bottom, I have square root of z squared. And the square root of z squared, how many pairs? Just 1 pair. On the top, square root of 25 is 5. How many pairs of y's do we have? We've got 1 pair with 1 left over. Remember, the rule is you can have a square root in the numerator, you just can't have one in the denominator. So all of these examples that we've done, 1 through 5, have all ended with a perfect square in the denominator once we simplify. Okay, so that is the first objective. So we have learned how to divide radical expressions, just the basic ones. Now we're going to talk about what it means to rationalize the denominator. In other words, what do we do if it's not a perfect square on the bottom? Okay, so if there's not a perfect square, there's going to have to be something that we're going to have to do. The best way I can kind of compare it to something is fractions. So if I have 1/4 and I'm adding it to 1/8, I can't add them together unless they have common denominators. So what I do is I multiply this one by 2 over 2. Whatever I do to the bottom, I do to the top. That would give me 2/8 plus 1/8, and now I can add and get 3/8. The reason why that's okay to do is technically we just multiplied by 2 over 2. In other words, we multiplied by 1. If you multiply something by 1, you don't really change it. You just write it in a different form. We are going to be doing the same thing to some radicals, except we, instead of multiplying by 2 over 2, we might be multiplying by the square root of 2 over the square root of 2. But again, that's just fancy for the number 1. So keep that in mind as we do the next few problems. All right, so let's go through our steps. Step 1, we always simplify first to see if we can work with smaller numbers. And who knows, maybe if we simplify, we'll get a perfect square in the denominator and we don't have to rationalize the denominator. Step 2, we are going to multiply both the top and the bottom by the radical in the denominator. Now there's a bunch of different ways of doing these problems, so it's kind of difficult to cover all the different ways, but I'll do my best to show you different options. Step 3, we're going to always check and see in the end, can I simplify again? All right, so let's see what this looks like. Okay, so I split here. I look to see if I can simplify. I can't, there's not a number I can divide them both by. And unfortunately, 7 is not a perfect square. So I need to make a perfect square inside the denominator. So what I'm going to do is I'm going to multiply it by the square root of 7. Reason being, if I do that, I get a perfect square in the denominator, which that's the goal. I want a perfect square so that way when I simplify it, I no longer have a radical. Remember, a radical in the denominator is a big no-no. Can't have it. So this is called rationalizing the denominator. We're getting the denominator It's right now it's irrational. It's a square root of 7, and we're making it rational. We're getting rid of that square root. So that's why it's called rationalizing the denominator, changing it from an irrational number to now a rational number. Now here's the part where we can't forget. If I multiply the bottom by the square root of 7, I also have to multiply the top by the square root of 7. Remember, this is fancy for the number 1. I can multiply something by 1 and not really change the number. It just changes the form of the number. Okay, so we talked about how to multiply radicals. If they're both inside, I can multiply inside with inside. So this would be the square root of 21. Okay, so we already talked about the square root of 49 and 7. And here I have the square root of 21 on top. Now I have to check, can I simplify? Is there a perfect square I can divide 21 by? All I can see is 1 and 21 and 3 and 7. And the answer is no. Now some people try to simplify 21 with 7 and say that this is 3 over 1. We can't do that because 21 is inside, whereas 7 is outside the square root. We can't simplify inside with outside. So this one is already the answer. It's the square root of 21 over 7. So it's finished. Okay, so let's try another one just like that. If you want to pause and try this one on your own, feel free to do that. So we're going to split it first into the square root of 2 and the square root of 3. Can't simplify either of those. So I need to make the bottom a perfect square, and I can do that by multiplying it by itself. But whatever I do to the bottom, I need to do to the top. Again, that's fancy for the number 1. And the whole point of doing that is so that I can get the bottom to be a perfect square, which is a square root of 9. And on the top, I will get square root of 6, because inside with inside, I can multiply those. And the square root of 9, I know the answer to is 3. All right, do not simplify 6 with 3. 6 is inside, 3 is outside. Don't do that. I do want to see if I can split 6. So the only numbers I know that multiply to get 6 are 1 and 6 and 2 and 3. None of those are perfect squares. So in this case, I am finished, and that's my answer. All right, let's try some more examples. So I'm going to go ahead and split here. Square root of 6, square root of 8n. Now they're both inside, so I can simplify inside with inside. I can divide them both by 2. So I would get 3 and 4n. All right, so the bottom is not a perfect square just yet. It's very close. The square root of 4 is a perfect square, but n is not. All I need it to do is to make it an n squared. So here's where I have a few options. I can multiply everything by 4n. That would work. It's going to cause me more work in the end. Or I could be smart, and all I want there is to be one more n inside, so I'm going to put one more n inside, and that's what I'm going to multiply it by. But whatever I do to the bottom, I do to the top. Because if I do that on the bottom, I'm going to end up with the square root of 4n squared, which is a perfect square. And on the top, I have inside with inside, I get the square root of 3n. All right, so now that I have a perfect square, I'm going to simplify it to 2n. And on the top, I have the square root of 3n. Again, don't simplify your n's. One inside, one outside. This is our answer. All right, next one. Can't simplify 5 and 18. I'm going to split them here first. All right, so I could try to think of what I can multiply 18 by to get me a perfect square. It wouldn't be 1. 18 times 2, that would be, thinking 36. Yeah, and that would give us a perfect square. So that's one route. I can multiply by 2. Some people want to multiply by the same thing, by 18n, You could do that. Again, it might be more work in the end. I'm going to multiply it by the smallest number to get me a perfect square, which is 2, because like I said, that's going to give us 36. But that doesn't solve the problem of the n's. Right now I have 1 n, I need there to be 2, so I'm going to multiply it by another n, so that way I will get 36n squared, which is a perfect square. So whatever I do to the bottom, I need to make sure I do to the top, and that would give us, they're both inside, I can multiply them together, so that would give us 10n inside. And now I'm going to simplify the denominator, say what that square root is. That is 6n. And on the top, I have the square root of 10n. Can't simplify inside with outside, so that is my final answer. All right, this one's kind of tricky. All right, so I want to multiply, well, first off, I can't simplify 22 and 11. One's outside, one's inside. So I need to multiply the bottom number by something that's going to get me a perfect square. The only one that I can think of right now is to multiply it by itself. Because if I multiply it by itself, I will get the square root of 121, which will eventually give me an answer of 11 when I square root it. All right, but I need to multiply the numerator by the same thing. Here's where people go wrong. They want to say that this is the square root of 22. That's not the case because 22 is on the outside, so I'm going to keep it on the outside. Square root of 11 is on the inside, so I'm going to keep it on the inside. So that would give us that answer on top, 22 square root of 11. Now, here is where I can simplify. Because 11's on the outside and 22 is also on the outside. Now this is a division problem, so I'm going to divide these two. 22 divided by 11 is 2 over 1, and I don't need to write the 1 on the bottom, so I'm going to get rid of my fraction. And then I still have the square root of 11. So final answer here is 2 square root of 11. All right, feel free to pause here and try these 2 examples on your own. We'll go through them and see how you did afterwards. All right, let's split. We have the square root of 7s, and we have the square root of 3. I can't simplify any of them, so I'm going to multiply by the square root of 3 on both the top and the bottom. That will give me a perfect square on the bottom, which is the whole goal. It will simplify to 3 on the bottom. So I just got to clean up the top now. So the top, square root of 7s times 3, they're both inside. I can multiply them together. That would give me 21s. And I can't simplify either one of those. Okay, last, see if I can simplify in the end. I have inside and outside. Can't simplify inside and outside. So that's just our answer. All right, number 7 here. We're going to split square root of 6 over square root of 15h. They're both inside, so I can simplify here. I'm going to divide them both by 3. That would give me the square root of 2 and the square root of 5h. All right, now I can't have a radical in the denominator, so I'm going to multiply by itself. That way I can make it a perfect square, which would be 25h squared. And whatever I do to the bottom, I need to do to the top. They are both inside. I can put those together. 2 times 5 is 10, so square root of 10h. All right, last, now that I've got a perfect square, I'm going to go ahead and simplify that bottom, which would be 5h all over the square root of 10h. Now, check if you can simplify it. I've got inside, outside, cannot simplify inside and outside, so that's my final answer. All right, that's it for the notes today. If you have any questions, please shoot me a message on Schoology. All right, see you guys. Bye.